March 24, 1945. Dawn breaks gray and cold over the Rhine River near Wesel, Germany. The ancient waterway flows dark and swift, carrying with it the weight of history and the hopes of a dying Reich. From concrete bunkers carved into the eastern bank, German officers peer through field glasses at something that defies everything they thought they knew about warfare. Across the water, American soldiers move with mechanical precision. Trucks roll to the river's edge and transform. Steel panels unfold like origami. Rubber pontoons inflate with sharp hisses. What should take days is happening in hours. What should require massive cranes and construction crews is being accomplished by young men with calloused hands and determined faces. Oberst Heinrich Müller lowers his binoculars, his weathered face pale. Behind him, staff officers whisper in disbelief. They had studied American forces for years, dissected captured equipment, analyzed intelligence reports, but nothing had prepared them for this moment. Watching enemy engineers build a bridge longer than 3 football fields under artillery fire, completing it faster than any army in history had ever managed. Mein Gott, Mueller whispers, watching another pontoon section lock into place with clockwork efficiency. They are not building a bridge. They are building our defeat. The sound of American trucks crossing the completed span echoes across the water like thunder, each rumble marking another nail in the Wehrmacht's coffin. By March 1945, the Rhine River had become Adolf Hitler's final gamble. The mighty waterway stretched 820 miles from the Swiss Alps to the North Sea, serving as Germany's last natural fortress against the advancing Allied armies. For centuries, the Rhine had protected Germanic tribes from Roman legions, French armies from Prussian forces, and now it stood as the Third Reich's ultimate defensive bar. Hitler himself had declared it impregnable, ordering the destruction of every bridge and the fortification of every crossing point. The winter of 1944-45 had been brutal for German forces retreating across Western Europe. The failed Ardennes offensive, Hitler's desperate gamble known as the Battle of the Bulge, had cost the Wehrmacht its last strategic reserves. Now, behind the Rhine's dark waters, field marshals like Model and Kesselring prepared for what they knew would be Germany's final stand. They had good reason for hope. The Rhine was no ordinary river. It was a military engineer's nightmare. At Wesel, where the Americans would make their fateful crossing, the Rhine stretched nearly 400 meters wide. Its current ran swift and treacherous, swollen by spring snowmelt from the Alps. The water ran deep enough to swallow tanks, cold enough to kill a man in minutes. Both banks rose steep and muddy, offering few suitable approaches for heavy equipment. German engineers had spent months preparing defensive positions, mining approaches, and positioning artillery to turn any crossing attempt into a slaughter. The Wehrmacht's defensive doctrine seemed sound. Throughout military history, river crossings had been lengthy, complex operations requiring extensive preparation. Traditional pontoon bridges took days to construct under ideal conditions, weeks when opposed by enemy fire. The Germans had studied Napoleon's campaigns, analyzed Caesar's river crossings, and examined every major bridge-building operation in modern warfare. Their calculations showed that even if the Allies attempted a crossing, it would take at least 48 hours to span the Rhine. Plenty of time to mass artillery and launch devastating counterattacks. General Wilhelm Keitel, Hitler's chief military advisor, had confidently predicted that the Rhine would hold the Allies for months. German intelligence estimated that crossing such a wide, well-defended river would require massive preparations visible from the air, giving defenders ample warning. They expected to see the slow accumulation of bridging equipment, the positioning of heavy cranes, the methodical assembly of traditional pontoon bridges under constant artillery bombardment. What they didn't expect was American industrial genius coupled with Yankee ingenuity. While German engineers still thought in terms of the bridge-building techniques used in World War I, American factories had been revolutionizing military engineering. The M2 treadway bridge system represented a quantum leap in portable bridge technology, modular, lightweight, and designed for rapid assembly by ordinary soldiers rather than specialized engineers. But the Germans knew none of this as they watched American forces mass along the western bank. Intelligence reports spoke of unusual truck movements, strange equipment shipments, and intensive training exercises, but nothing that prepared them for what was coming. German commanders, educated in the careful, methodical warfare of European tradition, could not imagine the speed and audacity that American engineers would demonstrate. As March 1945 dawned, both sides prepared for what would become one of the most decisive moments of World War II. The Germans, confident in their defensive positions and the natural barrier of the Rhine, waited for a traditional river crossing operation they felt certain they could defeat. The Americans, armed with revolutionary engineering technology and the desperate urgency of men who could smell victory, prepared to shatter every assumption about what was possible in modern warfare. Traditional military bridge building in 1945 remained largely unchanged from Napoleon's era. European armies still relied on heavy, cumbersome pontoon systems that required specialized engineer units, extensive preparation time, and ideal weather conditions. German doctrine, refined through 2 world wars, emphasized methodical construction using massive steel pontoons, heavy timber decking, and complex anchoring systems that could take trained engineers 24 to 48 hours to assemble across a major river. The Wehrmacht's own bridge-building capabilities reflected this conservative approach. German engineers used the sophisticated but slow Brückengerät B system, steel pontoons weighing over 1,500 pounds each, requiring cranes for positioning and specialized tools for assembly. Each bridge section demanded precise measurements, careful alignment, and multiple inspection phases. While robust and capable of supporting the heaviest tanks, these bridges took enormous time and manpower to construct, making them vulnerable to artillery and air attack during the vulnerable construction phase. Soviet forces employed similarly methodical techniques, though their pontoon bridges tended to be cruder and more utilitarian. Red Army engineers had mastered river crossings through necessity, but their approach emphasized overwhelming numbers of men and equipment rather than technological innovation. A typical Soviet river crossing involved hundreds of engineers working for days to establish a single bridge, with massive casualties accepted as the price of eventual success. British engineering doctrine, influenced by centuries of military tradition, favored thorough preparation and careful execution. The Bailey Bridge, invented by British engineer Donald Bailey, represented the pinnacle of modular construction, prefabricated steel sections that could be assembled relatively quickly by trained crews. While revolutionary for its time, even Bailey Bridge construction across a major river like the Rhine required 12 to 18 hours of careful work by experienced engineers. American military engineers had been quietly revolutionizing this ancient craft. The U.S. Army Corps of Engineers, drawing on America's industrial expertise and manufacturing innovation, had developed the M2 treadway system during the early war years. Unlike traditional pontoon bridges that required heavy individual components, the treadway system used lightweight aluminum decking sections, inflatable rubber pontoons, and standardized connecting hardware that ordinary infantry could assemble with minimal training. The genius of the treadway system lay in its simplicity and modularity. Each pontoon weighed just 485 pounds when deflated, light enough for 4 men to carry. The aluminum treadway sections, manufactured in Detroit automotive plants, locked together with foolproof connecting mechanisms that eliminated the complex measurements and adjustments required by traditional systems. Most importantly, the entire system had been designed for rapid deployment. Inflatable pontoons could be ready in minutes. Treadway sections connected in hours rather than days. American training methods reflected this technological advantage. While European armies trained specialized bridge-building units for months or years, American engineers practiced rapid deployment techniques that could transform ordinary truck drivers and infantry into effective bridge builders. Training exercises emphasized speed, standardization, and redundancy. Multiple teams working simultaneously to reduce construction time and distribute risk. The industrial scale of American bridge production staggered European observers. Detroit factories that had once built automobiles now churned out treadway sections by the thousands. Rubber companies in Ohio and Pennsylvania mass-produced inflatable pontoons using techniques developed for aircraft manufacturing. The entire system reflected American industrial philosophy: standardized components, mass production, and emphasis on speed and efficiency over individual craftsmanship. But perhaps most importantly, American engineers had abandoned the European obsession with permanent, elaborate construction. The treadway system was designed to be temporary, expendable if necessary, and quickly replaceable. This philosophy reflected American industrial confidence. Why build one expensive, elaborate bridge when you could build 3 quick, simple ones? This mindset would prove crucial in the rapid-fire river crossings that would characterize the final months of the European War. German intelligence had captured examples of American bridging equipment, but they failed to grasp the revolutionary implications. Reports described the treadway system as lightweight and portable, But German engineers trained in traditional methods assumed this meant inferior quality and limited capability. They could not imagine that American industrial genius had created a system that was simultaneously lighter, faster, and more effective than anything in European arsenals. From German observation posts along the Rhine's eastern bank, the scene unfolding across the water seemed to violate the fundamental laws of military engineering. Oberst Heinrich Müller had commanded engineer units through 3 years of brutal warfare across Russia, France, and now Germany itself. He understood bridge construction intimately, the careful measurements, the precise calculations, the methodical assembly that characterized proper military engineering. What he witnessed on March 24, 1945, shattered every assumption he held about what was possible in warfare. The American trucks arrived at 9:45 a.m., rolling to the water's edge with mechanical precision. Mueller expected to see the usual signs of river crossing preparation, the careful surveying, the positioning of heavy equipment, the slow accumulation of bridging materials that would signal enemy intentions hours in advance. Instead, he watched soldiers leap from truck beds and immediately begin unloading components with practiced efficiency. No surveying equipment appeared. No heavy cranes positioned themselves along the bank. Just men with determined faces moving with purpose that seemed almost supernatural. "They are not following proper procedure," whispered Major Klaus Weber, Mueller's chief engineering officer. Weber had studied at the prestigious Military Engineering Academy in Munich, where he had memorized the bridge-building techniques perfected over centuries of European warfare. The American approach violated every principle he had learned. Where are their measuring instruments, their foundation preparations? This cannot possibly work. But it was working. Before German eyes, inflatable pontoons swelled to full size in minutes rather than the hours required for traditional steel pontoons. Aluminum treadway sections, so light that 2 men could carry what normally required 6, locked together with mechanical precision. Most shocking of all, multiple teams worked simultaneously along the riverbank, assembling parallel sections that would be connected in the water rather than built sequentially from shore to shore. The psychological impact on German defenders proved as devastating as the tactical surprise. These were seasoned Wehrmacht officers who had witnessed the industrial might of the Soviet Union, the methodical precision of British engineering, the stubborn courage of American infantry. But they had never seen anything like this. Enemy soldiers accomplishing in hours what German doctrine insisted required days. The very speed of construction seemed to mock German military tradition and engineering expertise. "They cannot maintain structural integrity at this pace," Weber insisted, even as he watched American trucks beginning to cross the completed span. "The connections cannot be properly tensioned. The load distribution cannot be calculated. This bridge will collapse under the weight of their own vehicles." But the bridge held. Tank after tank rumbled across the floating span, each successful crossing another blow to German confidence and another proof of American technological superiority. The sight of ordinary American soldiers accomplishing what German engineers considered impossible had profound implications beyond mere tactical surprise. For years, Nazi propaganda had dismissed Americans as soft, undisciplined, and technologically inferior. The Übermensch ideology that had driven German military thinking insisted on Germanic superiority in engineering, organization, and military science. Yet here, across the Rhine, ordinary GIs were demonstrating capabilities that exceeded anything in German experience. Major General Wilhelm Bittrich, commanding the 2 SS Panzer Corps defending the Rhine sector, received reports of the bridge construction with disbelief that gradually transformed into despair. His staff officers, trained in the methodical warfare of European tradition, struggled to comprehend what they were witnessing. Intelligence reports spoke of multiple bridge sites being prepared simultaneously, of American engineering units working with impossible speed, of crossing operations that violated every principle of German military doctrine. "If they can build bridges this quickly," Bittrich confided to his chief of staff, "then every river in Germany becomes useless as a defensive barrier. The Rhine was our last hope, and they have made it meaningless." The general's words reflected a growing realization among German commanders that they were not simply facing superior numbers or better equipment, but an entirely different approach to warfare, one that emphasized speed, flexibility, and industrial efficiency over traditional military virtues. The German officers watching from their bunkers could not know that they were witnessing the culmination of American industrial philosophy applied to military engineering. The rapid bridge construction reflected not just superior equipment, but a fundamentally different mindset about warfare itself. Where German military thinking emphasized careful preparation and methodical execution, American doctrine stressed speed, adaptability, and the willingness to accept calculated risks in pursuit of decisive advantage. The technological revolution that enabled American engineers to span the Rhine in record time represented far more than superior equipment. It embodied a complete reimagining of how industrial nations could wage war. The M2 treadway bridge system emerged from American automotive factories, aircraft plants, and rubber manufacturers, representing the marriage of civilian innovation with military necessity that would define American military superiority for generations to come. Detroit engineers who had perfected assembly line production for Ford and General Motors applied their expertise to military bridge construction. The treadway sections, manufactured with automotive precision, featured standardized connections that eliminated the complex measurements and adjustments required by traditional European systems. Each component had been designed for interchangeability, allowing damaged sections to be quickly replaced and entire bridges to be modified on the fly to accommodate changing tactical situations. The rubber pontoons themselves represented a breakthrough in materials science, developed by companies like Goodyear and Firestone using techniques pioneered for aircraft fuel tanks. These inflatable sections could be deflated for easy transport, then rapidly inflated using compressed air systems mounted on standard military trucks. Unlike traditional steel pontoons that required heavy lifting equipment and careful positioning, the American system could be deployed by ordinary soldiers with minimal training, but the true genius lay in the system's emphasis on parallel construction. Traditional bridge building required sequential assembly. Each section had to be completed and tested before the next could begin. The American treadway system allowed multiple teams to work simultaneously, assembling bridge sections that could be connected in the water using specialized joining equipment. This parallel approach reduced construction time exponentially while distributing risk across multiple work crews. The psychological warfare implications proved as significant as the tactical advantages. German forces defending river lines had always counted on the time required for bridge construction to organize counterattacks, position artillery, and mass reserves for decisive intervention. The rapid deployment of American bridges shattered this defensive calculus, leaving German commanders unable to respond effectively to crossing operations that seemed to materialize out of nowhere. American training methods reflected this technological superiority. While German engineers required years of specialized education and extensive apprenticeships, American bridge-building teams could be trained in weeks. The standardized components and simplified assembly procedures meant that ordinary infantry units could construct bridges that previously required specialized engineer battalions. This democratization of military engineering multiplied American crossing capabilities while reducing dependence on scarce technical specialists. The industrial scale of American bridge production provided another overwhelming advantage. German forces might destroy one bridge, but American engineers could quickly construct another using equipment trucked in from massive supply depots. The Red Ball Express supply system, famous for keeping Patton's tanks fueled, also ensured that bridging equipment remained constantly available. German commanders faced the demoralizing reality that destroying American bridges was merely a temporary inconvenience rather than a strategic victory. Radio intercepts of German communications revealed the psychological impact of American bridge-building speed. Wehrmacht officers reported construction times that their superiors initially dismissed as impossible or exaggerated. When multiple independent sources confirmed the same incredible speeds, German high command began to realize they were facing capabilities that exceeded their worst fears about American industrial might. The broader implications extended far beyond individual river crossings. American rapid bridging technology meant that natural barriers, the fundamental organizing principle of European defensive strategy for centuries, had lost much of their military significance. Rivers that had channeled military campaigns since Roman times could now be crossed almost at will, forcing German defenders to abandon linear defensive strategies and attempt mobile defense with increasingly inadequate resources. American engineers had also solved the logistics challenge that had traditionally limited bridge construction. The M2 treadway system broke down into components that could be transported by standard military trucks, eliminating the need for specialized transport vehicles or rail infrastructure. This meant that bridge-building capability could be deployed anywhere American trucks could travel, giving field commanders unprecedented flexibility in choosing crossing sites and timing operations for maximum tactical advantage. The speed of American bridge construction also changed the mathematics of artillery defense. German gunners had traditionally counted on hours or days of warning to zero in on bridge construction sites and mass fires for maximum effectiveness. When bridges appeared in hours rather than days, German artillery found itself constantly reacting rather than proactively engaging construction sites, reducing the effectiveness of defensive fires and allowing American engineers to work with minimal interference. At exactly 8:35 a.m. on March 24, 1945, Captain James McAdams raised his hand and shouted the order that would shatter German defensive plans along the Rhine. "Let's build this bridge." The words carried across the muddy riverbank near Spellen, Germany, where Company E of the 17th Armored Engineer Battalion and Company C of the 202nd Engineer Combat Battalion had spent the pre-dawn hours positioning their equipment and preparing for what would become the most audacious bridge-building operation in military history. The statistics alone seemed impossible. The Rhine at this point stretched 1,146 feet across, longer than the Empire State Building is tall. German intelligence had calculated that crossing such a span would require at least 48 hours of construction time, giving defenders ample opportunity to mass artillery and launch counterattacks. American field manuals suggested similar timeframes under ideal conditions. But these were not ideal conditions. German artillery was already finding the range, enemy snipers held positions along the far bank, and the spring current ran swift and treacherous. 25 GMC trucks had arrived before dawn, each loaded with precisely calculated components of the M2 treadway system. No excess equipment, no backup materials. Everything had to work perfectly the first time. As the trucks disgorged their contents, German observers across the river initially dismissed the activity as routine reconnaissance or minor crossing preparation. They had seen similar American probes at dozens of crossing sites along the Rhine, all easily repelled by concentrated artillery fire. The first sign that something unprecedented was unfolding came at 9:15 a.m. when American engineers began inflating rubber pontoons with compressed air systems. Instead of the slow, methodical positioning of traditional steel pontoons, inflatable sections swelled to full size in minutes. German artillery observers, trained to recognize the lengthy preparation phases of conventional bridge construction, found themselves struggling to adjust their targeting as bridge components appeared with bewildering speed. By 10:30 a.m., parallel construction teams had assembled over 200 feet of treadway sections along the riverbank. Unlike traditional bridges that had to be built sequentially from one shore to the other, the American system allowed multiple sections to be prefabricated on land and connected in the water using specialized joining equipment. German defenders watched in growing amazement as what appeared to be separate construction projects began revealing themselves as components of a single, massive bridge. The breakthrough moment came at 11:45 a.m., when American engineers successfully connected the first prefabricated sections in the Rhine's swift current. German artillery, finally recognizing the scope of the American operation, began concentrating fire on the construction site. Shells screamed overhead, sending geysers of water and mud skyward. 20 casualties fell among the engineer teams, but work never stopped. Wounded men were evacuated and immediately replaced by reserves who continued assembly operations without missing a beat. Lieutenant William Doibel of Kansas City, supervising one of the construction teams, later described the surreal experience of building a bridge under fire. "I guess we just were scared and wanted to get out of here in a hurry," he would tell reporters. But fear translated into unprecedented efficiency. Men worked with mechanical precision, each knowing that speed meant survival and delay meant death. The familiar rhythm of training exercises became a desperate race against German artillery and the approaching limits of human endurance. By 1 p.m., the bridge had reached the halfway point across the Rhine. German observers could no longer dismiss what they were witnessing as a minor operation. Reports flooded up the chain of command describing construction speeds that violated every principle of military engineering. Field Marshal Walter Model, commanding Army Group B, initially refused to believe the reports. "No army can build a bridge that quickly," he insisted. "The intelligence must be wrong." But the intelligence was correct. American engineers were rewriting the rules of military engineering in real time. At 2:30 p.m., with German artillery fire intensifying and enemy aircraft beginning to strafe the construction site, the final treadway sections locked into place. The longest pontoon bridge ever constructed under combat conditions spanned the Rhine, 1,146 feet of aluminum decking supported by 93 inflatable pontoons, completed in under 9 hours by men who had never attempted anything remotely similar. The moment of truth came at 3:00 p.m. when the first American truck rumbled onto the bridge approach. German artillery observers held their breath, expecting to see the flimsy-looking structure collapse under the weight of military vehicles. Instead, the bridge held firm as truck after truck crossed safely to the eastern bank. Tanks followed, then artillery pieces, then entire convoys of supply vehicles. What had been an impassable barrier at dawn had become a superhighway by afternoon. Captain McAdams, exhausted and covered in mud, watched the steady stream of American vehicles crossing his impossible bridge. The radio crackled with reports from other crossing sites, similar bridges appearing with equal speed at multiple points along the Rhine. The German defensive strategy, based on the assumption that river crossings would provide warning time and opportunity for counterattack, was collapsing in real time. The successful completion of the Spellen Bridge at 3:00 p.m. triggered a cascade of realizations that would fundamentally alter German strategic thinking and accelerate the collapse of Nazi resistance. As the first Sherman tanks rumbled across the floating span, German radio networks exploded with frantic communications that Allied intelligence intercepts would later reveal captured the moment when Wehrmacht leadership understood their situation had become hopeless. Unmöglich, das ist unmöglich. The voice of Major General Wilhelm Bittrich, commanding the 2 SS Panzer Corps defending this sector, crackled over German radio frequencies as he watched American armor streaming across a bridge that shouldn't have existed. His staff officers, trained in the methodical warfare of European tradition, struggled to comprehend tactical implications that seemed to violate everything they understood about military engineering and defensive strategy. The psychological impact proved as devastating as the tactical surprise. For hours, German artillery had pounded the construction site, scoring direct hits that should have destroyed any conventional bridge. Yet the American structure absorbed damage, shed destroyed sections, and continued functioning. When German shells destroyed several pontoons at 4:30 p.m., American engineers simply bypassed the damaged area and rerouted traffic while replacement sections were trucked in and installed. The bridge seemed almost organic in its ability to adapt and survive. At 5:15 p.m., disaster struck when a ferry carrying a German tank broke loose from its upstream mooring and drifted into the American bridge. The collision destroyed 9 pontoons and sent several treadway sections beneath the dark water. German observers cheered, certain that the Americans would require days to repair such extensive damage. Instead, they watched in stunned silence as American engineers used explosive charges to separate the damaged section, allowing traffic to resume on the undamaged portions while repair crews went to work with clockwork efficiency. The repair operation that followed demonstrated American industrial philosophy in its purest form. Rather than attempting to salvage damaged components, engineers simply discarded destroyed sections and installed fresh equipment trucked in from supply depots. Within hours, the bridge was longer and stronger than before the collision. German defenders, accustomed to the careful conservation of scarce resources, could barely comprehend such industrial abundance. By 6:00 p.m., intelligence reports were flooding German headquarters with accounts of similar bridges appearing at crossing sites throughout the Rhine sector. At Remagen, American forces had captured an intact railway bridge and were pouring reinforcements across. At Oppenheim, Patton's Third Army had thrown a pontoon bridge across the river with similar speed. At Boppard, another American bridge was nearing completion. The Rhine, Germany's last great defensive barrier, was being systematically nullified by American engineering capabilities that exceeded German worst-case scenarios. Field Marshal Kesselring, commanding German forces in the West, convened an emergency staff meeting as reports continued arriving. The mathematics of the situation were inexorable. German mobile reserves could not possibly respond to multiple simultaneous crossings, especially when each bridge could pour across a full armored division in hours rather than days. Traditional defensive doctrine assumed that river barriers would channel enemy attacks into predictable crossing points where reserves could be concentrated for counterattack. American bridging technology had shattered this assumption completely. The radio intercept that would later become famous among Allied intelligence analysts came at 7:30 p.m. when a German regimental commander reported to his division headquarters. "The Americans are not building bridges. They are building our defeat." Every calculation we have made, every plan we have prepared, has become meaningless. They cross rivers like other armies cross fields. German commanders found themselves facing a strategic nightmare. Every river in Germany, the Weser, the Elbe, the Danube, had suddenly become potentially meaningless as defensive positions. If Americans could cross the mighty Rhine in a single day, then no water barrier could be counted on to provide the time needed for effective defense. The entire German defensive strategy for protecting the homeland had to be reconsidered from first principles. The collapse of German Rhine defenses accelerated dramatically as word of American bridge-building capabilities spread through Wehrmacht ranks. Frontline units, already demoralized by months of retreat and diminishing supplies, began to question the point of continued resistance. If the Americans could appear anywhere at any time, if rivers provided no protection, if defensive positions could be outflanked within hours, then what hope remained for meaningful resistance? By midnight on March 24th, American forces had established 6 separate bridgeheads across the Rhine, with more bridges under construction at additional sites. German reserves, stretched thin after months of attrition, found themselves unable to respond effectively to any single crossing, much less the coordinated offensive that was overwhelming their defenses. The speed of American operations had compressed traditional military timeframes, giving German commanders no opportunity to organize effective counterattacks. The final realization came in a radio message intercepted by Allied intelligence at 2:00 a.m. on March 25th. A German division commander reporting to his corps headquarters transmitted what would become the epitaph for Wehrmacht hopes. "The war is over. We simply did not understand what we were fighting against." The morning of March 25, 1945 dawned on a transformed strategic landscape. Across 6 separate crossing points along the Rhine, American armor and infantry poured into the German heartland through bridges that had materialized with impossible speed. The psychological shockwaves from the previous day's engineering demonstrations rippled through German command structures, triggering a cascade of surrenders, retreats, and strategic collapses that would accelerate the war's end by months. In prisoner-of-war camps hastily established behind American lines, captured German officers struggled to comprehend what they had witnessed. Major Klaus Weber, the engineering officer who had insisted American bridge construction was impossible, sat in stunned silence as Allied interrogators showed him photographs of the completed spans. "We calculated that crossing the Rhine would require weeks of preparation and days of construction," he told his captors. "You did it in hours. Our entire defensive strategy was based on assumptions that proved completely wrong." The testimonies of captured German commanders revealed the profound psychological impact of American engineering capabilities. General Wilhelm Bittrich, formerly of the 2 SS Panzer Corps, confided to interrogators, "When I saw your engineers building those bridges, I knew the war was lost. Not because of the tactical situation, but because it showed us we had fundamentally misunderstood American capabilities. If you could do the impossible with river crossings, then everything else we thought we knew about warfare might be equally wrong." American intelligence officers processing hundreds of prisoner interviews discovered that German military doctrine had been based on assumptions about engineering capabilities that American industrial methods had rendered obsolete. Wehrmacht training manuals specified minimum time frames for river crossings that were 3 to 4 times longer than American engineers were actually achieving. German defensive plans had been predicated on warning times that no longer existed, counterattack opportunities that never materialized, and resource calculations that underestimated American industrial abundance by orders of magnitude. The collapse of German Rhine defenses triggered strategic decisions that reverberated throughout the Nazi command structure. Adolf Hitler, receiving reports of multiple American bridgeheads, initially ordered counterattacks that his generals knew to be impossible. Army Group B, already weakened by months of attrition, simply lacked the mobile reserves necessary to respond effectively to simultaneous crossings across hundreds of miles of front. Field Marshal Model, one of Germany's most capable defensive commanders, reported to Berlin that continued resistance west of the Rhine was militarily meaningless. The speed of American operations had compressed traditional military timeframes to such an extent that JURES, manned defensive responses, became reactive rather than proactive. Artillery positions, carefully surveyed to cover traditional crossing sites, found themselves unable to adjust to the rapid appearance of bridges at unexpected locations. Mobile reserves, positioned to respond to lengthy crossing operations, discovered that American bridgeheads were already consolidating before German units could even begin movement to counterattack positions. German logistics networks, already strained by months of retreat and aerial bombardment, proved completely unable to support the rapid redeployment of forces necessary to counter American breakthrough operations. Units ordered to respond to Rhine crossings found themselves without fuel, ammunition, or transportation. The careful defensive preparations that had consumed months of effort were bypassed and rendered irrelevant within hours of American engineering operations beginning. The technological gap revealed by American bridge-building capabilities extended far beyond military engineering. German officers recognized that they were confronting an industrial system that had solved logistical and manufacturing problems that European armies still considered intractable. The standardization, mass production, and rapid deployment capabilities demonstrated by American engineers reflected broader American advantages in industrial organization, resource management, and technological innovation. Intelligence reports from other sectors confirmed that American engineering capabilities were not limited to the Rhine crossings. Similar rapid bridge construction was occurring throughout the American advance, turning rivers from barriers into minor inconveniences. The Ruhr Pocket, Germany's industrial heartland, found itself effectively cut off not by overwhelming force but by American engineers who could appear at any river crossing within hours rather than days. The human cost of German miscalculations became apparent in casualty reports from units that had attempted to defend river lines against American crossing operations. German forces, positioned to fight lengthy defensive battles against traditional crossing attempts, found themselves overwhelmed by the speed of American operations. Units that might have conducted effective delaying actions against conventional attacks were simply bypassed and cut off before they could adjust to American tactical innovations. The strategic implications of American bridge-building superiority extended far beyond the immediate tactical victories along the Rhine. As news of the rapid crossings spread through German military and civilian populations, the psychological foundation of continued resistance began to crumble. The Wehrmacht's carefully cultivated image of technical and organizational superiority, a cornerstone of Nazi ideology, had been shattered by the sight of American soldiers accomplishing the impossible with apparent ease. German military academies, which had trained generations of officers in the methodical warfare perfected during centuries of European conflict, found their doctrines suddenly obsolete. The Kriegsakademie in Berlin received urgent requests for guidance on countering American rapid bridging techniques, but German military theorists had no answers. Their textbooks contained no countermeasures for engineering capabilities that exceeded their understanding of what was technically possible. The collapse of defensive confidence rippled through German civilian populations as well. Radio broadcasts attempted to minimize the significance of American Rhine crossings, but civilians could observe the streams of refugees fleeing eastward and the absence of German counterattacks that propaganda had promised. The myth of German technological and organizational superiority, so carefully cultivated by Nazi propagandists, was being demolished by American engineers armed with inflatable pontoons and aluminum treadway sections. German industrial leaders, many of whom had collaborated with the Nazi war effort, began to recognize the futility of continued resistance. Factory owners who had witnessed American bombing campaigns understood the industrial capacity that lay behind American military operations. When they learned of bridge-building speeds that German industry could not hope to match, many began making private arrangements for surrender and post-war cooperation with occupying forces. The acceleration of German military collapse following the Rhine crossings surprised even Allied planners, who had anticipated months of continued fighting as German forces retreated toward Berlin. Instead, the demonstration of American engineering superiority had triggered a psychological collapse that made organized resistance increasingly difficult. German units, realizing that no defensive position could be considered secure against American crossing capabilities, began surrendering in unprecedented numbers. American logistics officers planning for extended campaigns across Germany found themselves struggling to keep pace with advancing forces that were meeting minimal resistance. The bridges that had made the Rhine crossings possible became critical supply arteries, supporting operations hundreds of miles beyond the original crossing sites. The M2 treadway system, designed for temporary use, was being employed in semi-permanent installations that kept American armor supplied and mobile throughout the final campaigns. The broader implications for post-war military doctrine became apparent as Allied planners assessed the lessons of the Rhine crossings. Traditional defensive strategies based on river barriers would require fundamental revision in light of American engineering capabilities. Military academies throughout the Western world began incorporating American rapid bridging techniques into their curricula, recognizing that warfare had been permanently altered by industrial innovations developed in Detroit factories and Akron rubber plants. Soviet observers, watching American operations from their own sectors along the Eastern Front, drew their own conclusions about American industrial and military capabilities. Stalin's intelligence services filed detailed reports on American bridging technology, recognizing that future military planning would have to hunt for capabilities that exceeded anything in Soviet arsenals. The Rhine crossings thus contributed to post-war tensions as the Soviet Union recognized the technological gap that would need to be addressed in any future conflict. The economic implications proved equally significant. American bridge-building capabilities had been achieved through industrial methods that could be rapidly scaled and widely deployed. German economic planners, preparing for post-war reconstruction, realized they would be competing with an American industrial system that had solved fundamental problems of standardization, mass production, and rapid deployment that European industries were only beginning to address. The human stories emerging from German prisoner of war camps revealed the personal impact of technological shock on individual soldiers and officers. Veterans of the Eastern Front, accustomed to brutal but comprehensible warfare against Soviet forces, found themselves demoralized by American capabilities that seemed to violate natural law. Many German prisoners expressed relief at being captured by forces whose technological superiority made continued resistance seem not just futile but almost absurd. By the end of March 1945, German resistance west of the Rhine had effectively collapsed, not through overwhelming force, but through the demonstration that American industrial capabilities had rendered traditional defensive strategies obsolete. The bridges that American engineers had thrown across the Rhine in hours rather than days had accomplished more than tactical victory. They had shattered German confidence in the fundamental assumptions upon which their military doctrine was based. The Rhine crossings of March 1945 marked more than a tactical victory or even a strategic breakthrough. They represented a fundamental shift in the nature of warfare itself. The German generals who wept at the sight of American trucks transforming into bridges in minutes were witnessing the emergence of a new form of military power that would reshape global conflict for generations to come. The speed and efficiency of American bridge construction embodied principles that would define American military doctrine throughout the Cold War and beyond. Technological superiority through industrial innovation, rapid deployment capabilities, and the ability to project power across any geographic barrier. The same industrial philosophy that enabled Detroit engineers to span the Rhine would later put American forces anywhere in the world within hours, from the Berlin airlift to the lunar surface. For the German officers who had devoted their careers to mastering the careful, methodical warfare of European tradition, the American achievement represented something more profound than military defeat. It was the death of an entire way of thinking about conflict. The Wehrmacht's emphasis on technical perfection, detailed planning, and graduated escalation had been swept aside by American pragmatism, industrial abundance, and willingness to accept calculated risks in pursuit of decisive advantage. The broader implications extended far beyond military engineering. The Rhine crossings demonstrated that American industrial civilization had developed capabilities that fundamentally altered the strategic balance of power. Rivers, mountains, and oceans, the geographic features that had shaped military strategy for millennia, were becoming increasingly irrelevant in the face of American technological innovation and industrial capacity. The image of American soldiers casually accomplishing the impossible while German professionals looked on in amazement would become a metaphor for the broader transformation of global power relationships in the 20th century. The same combination of industrial innovation, pragmatic problem-solving, and organizational efficiency that built bridges across the Rhine would later build the interstate highway system, the space program, and the technological infrastructure that would define American leadership in the post-war world. Perhaps most significantly, the Rhine crossings revealed that wars could be won not just through superior force or better strategy, but through fundamental advantages in problem-solving approaches and industrial capabilities. The German generals who wept at their inability to comprehend American achievements were witnessing the emergence of a new kind of superpower, one whose strength lay not in traditional military virtues but in the ability to innovate, adapt, and deploy solutions to previously impossible challenges.